Okay, so guys, in this video we have to solve some differentiation word problems, and in the upcoming 2 to 3 videos we will be discussing the word problems related to the differentiation. Okay, so basically it's not a thing which is new. We are basically going to compile all of the things which we have studied in the previous videos related to the derivatives and the differentiation, and we will use them to solve some real life problems. Okay, so the first question actually says find two positive integers. Okay, so it is asking you to find the positive integers whose sum is 30 and their product will be maximum. First of all, the sum is 30, so x plus y will be 30 and their product will be maximum, so their product should be maximum. And what is meant by maximum? It means that the graph will be downwards, it will be concave down, and you will get the maximum value the function can achieve. First of all, we have to declare this y. So x plus y is equal to 30. Now, how can we find y? We can derive equation for y by moving this x towards the opposite side of the equation. So this will be much easier to solve by putting it into another equation. So we can also write, instead of writing x plus y is equal to 30, we can write this equation can be written as x plus 30 minus x equals to 30. The first integer is x and the second integer is this thing right over here, 30 minus x. What is the question based on? The question is based on this thing right over here, the product of these two things. So the product should be maximum. So now our function becomes the first integer multiplied by this second integer. So this is the function and this has to be maximum at some value of x. So how can we find the value of maxima? First of all, let's take the first derivative. We can use the product rule. This would be or we can actually multiply this x, then it will be much more simpler. So we have 30x minus x multiplied by x will be x squared. So the derivative of 30x will be 30 minus the derivative of x squared will be 2x. Now we can set it equal to 0 as a second step. 30 minus 2x, 2x will be equal to 30 and x will be equal to 15. So we have the value of x as 15. And now let's determine the second value. We know that y is actually equal to 30 minus x. We know the value of x is 15. So 30 minus 15, which is also equal to 15. So y is 15. Now the first integer is 15 and the second integer is 15. So now we can find the product by putting it into the function. So function at x is equal to x times 30 minus x. So the function at 15 will be 15 times 30 minus 15. So what will be the answer? It will be 225. Now this is the product of x and y. And at this point, at x is equal to 15, the function has a maxima. You can actually check that by taking the second derivative of this function right over here. So by taking the second derivative, so the derivative of 30 will be 0, derivative of negative 2x will be negative 2. So we have negative 2. Now negative 2 is actually lesser than 0. The graph will be opening downwards and we have the maxima. So yeah, it is proved that at this point we have a maxima. Okay, now let's see one more example. The question actually says that divide 20. Okay, so you have given a number 20 into two parts. You have to basically divide it into two parts so that the sum of the squares will be minimum. So you have to basically divide 20 into two parts. Let's say those parts are x and y, and then you have to take the sum of these squares. So you have to basically take x squared plus y squared, and this should be equal to a minima. Okay, so clearly x squared plus y squared will be my function, but first of all we know that the question is saying x plus y should be equal to 20. Okay, because we have divided those things into the two parts. So y can be derived as 20 minus x. So instead of writing x squared plus y squared, we can write x squared 20 minus x whole square, which will now be my function. Okay, now let's take the first derivative. So the derivative of x squared will be 2x plus the derivative of 20 minus x squared. Now let's open this whole square formula first of all. Okay, so 20 squared is 400 minus 2 times 20 will be 40x plus x squared. So now let's put this thing over here. Derivative of 400 minus the derivative of 40x plus the derivative of x squared plus derivative of 400, of course it will be 0, minus the derivative of 40x will be negative 40 plus the derivative of x squared will be 2x. So we have 2x, negative 40 plus 2x. So we have 2x plus 2x, 4x minus 40. Now let's make this equal to 0. So 4x minus 40, 4x will be equal to 40 and x will be equal to 10. So we have the value of x as 10. Now we can determine the second value. Y is actually equal to 20 minus x, and we know that x was 10, which we just calculated right now. So 20 minus 10, y will be equal to 10. So yeah, this condition actually matches. X is 10, y is 10, 10 plus 10 gives us 20. So yeah, the condition is correct. And at this point, x is equal to 10, the function has a relative minima. How? We can check it using the second derivative test. So the second derivative of this thing right over here, the derivative of 4x will be 4 and the derivative of 40 will be 0. So the 4 is actually greater than 0. So the graph will be concave up and we will have the value of minima. Okay.